Hello everyone, today we are going to talk about advanced SQL queries. In the previous two videos we talked about the basics of SQL and then we moved on to intermediate commands, but in this video we are going to start advanced queries. So without any further ado, let's begin. Sometimes we have missing values in some of the columns of tables and we want to find those values, so we can either remove them from the dataset or we can fill them with appropriate values. We cannot find null values with the help of the comparison operators, but instead we need to use the is operator in the where class. So let's see this with the help of an example. For example, there are some missing values in the email column of customer table. If I want to find those null values and if I write this by the use of the comparison operator, it will not return the exact result that we need. If I say select star from customer where email is equal to null, and if I add semicolon and press enter, it says that there is nothing or there is no data where the email is null. But I know that there are records where the email column has missing value. So it means that we cannot find null values with the use of the comparison or equal operator. So instead we use the is operator. I will say select star from customer where email is null. So for finding null values we need to use the is operator. Let me press enter, and yes, it returns these four records with ID 20 to 10, 25 and 100, where you can see that the email column does not have any value. So whenever we want to find null values, we need to use the is operator, and if we want to find those values which are not null, then we will use the logical operator not along with is. So for example, select star from customer where email is not null. As I said in my previous video, that the not logical operator will convert true to false and false to true. So where is null is true, and if we say where is not null, it will return true to false, and it will return those records where the email column has values. So if I press enter here, it returns all those records where the email column has values, and it will not return the records where the email column has missing values. So let me press Q to exit this and clear the screen. In the previous videos we just worked on the customer table. Let's work on the orders table in this video. For example, let me describe the table orders, and it says that we have ID, customer ID, order date and amount. So let me just select star from orders, and this is the result that we have. We have ID, customer ID, order date and amount. In this table we can see that the amount column is not in order. For example, if we want to see the smallest values on top and the largest values at the end, we can use another class that is called order by class. So let me open Notepad so I can write it here. Order by class actually orders the select command result, and it returns the ordered result to us. So it can order the data by ascending order or by descending order, and whichever we specify, it will return the result according to our requirements. So if we do not specify the ascending or descending order, it will by default return the results in ascending order. So let's see this in action. And remember that we use order by after the where class. Okay, if we do not have where class, we can use it after from class, but if we do have where class in a statement, then we need to use order by after the where class. So let me write select star from orders. This time orders is the table name currently, and order by a column name. So column is amount column. I want to order the results by amount column, and let's do not specify the ascending or descending order. it by default will return the results in ascending order. If I press enter, we can see that the first value at 1850, then we have 2050, then 2550, and if we come down, the values will get larger and larger. So it has ordered the results by amount column, and the smallest value is on top and the largest value is at the end. Let me quit this by pressing Q and clear the screen. Let me press arrow top key so I can go to this statement. Select start from orders, order by amount. Let's mention order by descending order. So for descending order, we write DESC, desk, or descending order. This time if I press enter, it will return the results where the top values are the largest values and the bottom values are the smallest values. If we come down, we can see that the values are getting smaller below. We can see at the top it was 9,000, now we have 7,500, and if we scroll down we will have 6,000, 5,000, and so on. Now that we learned order by and we also learned how to find null values, let's move on to another topic, that is aliases. Alias. Alias is a name given to a column or a table in SQL. It is the temporary name that we want to see a column in the result by this specific name, or if we want to give a table a temporary second name. So alias is just a second name given to a column or a table. For example, if I say select ID, comma, name as employee name. So I want to see, sorry, not employee name, customer name. So I want to see the name column of the customer table as the customer name in the results. So remember, I have said this before in my previous videos, that whenever we want to work on text or string, we need to include that in single quotes, but while giving an alias to a column, we must enclose it in double quotes, because it's a second name, not the actual column name, or not the actual value that we want to give to a column or a table. So here we just want to see the name column as the customer name in the result set. So I'm saying that select ID as ID. I'm not giving it a second name, but for name I'm giving it a second name, that's customer name, comma, email as customer primary email, comma, phone and address. So I changed the names of name column and email column just for the result of this one query. It will not change the name in the actual table. It will just show the name column as the customer name in the result set. That's it. If I add semicolon, press enter. Okay, I just missed the from class. So from customer, press enter. That's it. Now you can see that we have ID column as it is, but the name column was renamed just for this one query result. That's customer name, then customer primary email, phone and address. So we can give an alias to a column name in an SQL query, but that will just be a temporary name for one result set. That's it. If I press Q and clear the screen, and now I describe the customer table, it will have the same column names like ID, name, email, phone, address. There will be no change. Similarly, we can give an alias to a table name. For example, select c.id, comma, c.name from customer as C. I am giving a new name to the customer table, that is C. But again, this is an alias and just given in this query for this one result set. We can, whenever we want to fetch data from 2 or 3 tables, we need to join them. Later on in this video, we will be studying joins. In joins, we need to give alias to a table name because we want to shorten our queries. If we give full names to each column of every table, then it will be a very long query. Therefore, for shortening our query, we need to give aliases to column names and also to the table names. So here I am saying that select c.id, that means customer.id. If I just write customer.id comma customer.name from customer table, it will return the result according to this query. There will be no problem because we are fetching data from customer table and we are using customer.id. So that doesn't matter, we can do that. If I press enter, it will return the result. But instead of providing the full table name, we can give it an alias, like select c.id, c.name, comma, c.email from customer as c. Here the as keyword is optional. If you write as c or if you write c, both of them work the same. For example, select c.id, c.name, c.email from customer as c. It means I'm providing the name c to the customer table for this one query. Let me add semicolon, press enter, and it is returning the data that we need. This time, let me bring back that query. I'm removing the as, so you can understand that that is just optional. You can use it or you can ignore it. If I return the result, it has the same result. Most of the times, for just exploring the tables or the data, we do not want to see the entire data set of the table. For example, the customer table has 2000 records. Whenever we write a query, it returns all the records. For the sake of just overviewing a table or the data, we just want to see 5 or 10 records, not all the data of the table. So we need to limit the result set whenever we write a query, and we can do that as well with the use of the limit class. Limit class. Remember, limit class should be the last class in the order of SQL classes. The first class is the select one, the second class is from, the third one is where, the fourth one that we saw before was order by, and now the last one is limit. Remember, we can have other classes in between, but limit class should be the last one. So we can limit the result as I said before. For example, if I say select everything from the customer table, if I run this, you can see that it returns all the data and it has no limit because it has 2000 records and it is returning that. But we do not want to see all the data here. We just want to have an overview of this data. So let me bring back that query, and at the end I am saying that limit the result set to only 5 records. So limit 5 means that I just want to see 5 records, 1, 2, 3, 4, 5, that's it. And this is up to us if we want to limit it to 5 records, 1, 10, or as many records that we want. We can limit it. So limit is very useful here, and we can use it with where class as well. For example, select, this time I'm fetching data from orders table. Select star from orders table where the amount value is greater than 7,500. If I run this query, oops, I missed from. Select star from orders table where amount is greater than 7,500. See, it returns all the records that fulfills this condition, and we have 183 records where the amount column is more than 7,500. So let me bring back that query. Let me first clear the screen. So let me bring back this query, and now I want to limit this to only 10 records. So I'm adding limit with where class, so you can see it how it works. And it returns 139 because we have given it a condition. So all the 183 records that fulfills this condition will be returned, but that will be limited by the limit class, and we are only seeing 10 records here. We have been talking about databases, primary keys, foreign keys, and we have used a select command with its variations. We studied a lot of things, but the actual question still remains that because we have linked tables and database through the primary key and foreign key concepts, now how can we join these tables? For example, if we see the orders table, Let me describe that again. It has ID, customer ID, order date and amount. And let's explore this. For example, select star from orders and limit that to 5 records. We can see that we are seeing customer ID, but we do not know who the person is. We must see the person's name or the person's email or person's address instead of just the customer's ID. So for seeing the customer name instead of customer ID in the orders table or customer's email here, we must use a concept that is called joins. In SQL, joins is the most important topic and we must learn that by heart. So we have joins for joining more than one table. So 2 or 3 or 4 or any number of tables, we must use joins. There are 4 types of joins. The first one is inner join that you can see in this notepad. The second one is left outer join. We can say left join or left outer join. Both of them means the same. Then we have right outer join. Then we have full outer join. To illustrate these joins better, I have added 2 temporary tables into this database. Let me show all the tables. Remember, in the previous videos, we did not have projects and employees tables. I added those tables specifically for the purpose of learning joins. So let me describe both of them. /d employees first, and this has ID, name and manager ID. Let me select star from employees. It has only 10 records. Okay, it has 10 records, ID, name and manager ID. Remember that you can see here the employee table's primary key is ID. Then there is a foreign key, manager ID, which references back its own table. So manager ID references employee ID. It means this is the foreign key that links employee with employee. What does that mean? It means that for ID number 10 : there is no manager. For John, Vic, Jane and Smith, the manager is ID number 3. It means that Jasmine, ID number 3, is the manager of John, Vic, Jane and Smith. So the same ID from employee table becomes the foreign key as well. It means the same an employee from the employees table is the manager of other employees. So this is a very simple concept, because for example we have 10 employees and one of them is the manager of all, or 2 of them are the managers of some of the employees here. So an employee is the manager of other employees. That's very simple. Same, we have ID number 10 as the manager for Jasmine, Willie, Brad, Hawk and Peter. So ID 10 is Colin, and Colin who does not have a manager, who is the super manager or the top level manager. He's on the top, so he is the manager of Jasmine, Willie, Brad, Hawk and Peter. So the same ID becomes the foreign key in the same table. So this is the employees table. Let me describe the projects table. In projects we have 3 fields: ID, name and employee ID. So employee ID is the person responsible for this project. Let me select star from projects and see the data. Okay, so for some of the projects that you can see, we have employee ID, but for some we do not have. It means these projects are in the initial stage and the manager or the responsible person is not yet known for them. But for project 1 to 5 we have employee IDs. It means they have the responsible people. Let me clear the screen and start off with inner join. Joins 2 tables. Inner join will join tables based on common values between 2 tables. It means it will ignore those records who do not have matching values. We saw in the projects table that for some of the projects there was no employee ID. So if I join these 2 tables with the help of inner join, it will return only those records that have matching values in both of the tables. It means the employee ID is present in employee table and the employee ID also present in projects table. Those records will be returned, and the ones that do not have employee ID in projects table, that will be ignored. So let me illustrate this with the help of an example. Select, in this case we must give the table name along with the column name, because in both of the tables, if I describe them again, /d employees and /d projects, in these two tables we have ID and name common in both tables. So if I write select ID and name from tables, SQL will not understand whether I am requesting the ID and name columns from employee table or from the projects table. So here we need to mention the table name along with the column name. How? Let's see. Select employee.id. So I'm saying that select ID from the employee table first, then employee.name, and then employee.manager ID. So I want all the columns from employees table. Then from the projects table, I also want to see all the columns. So here I am saying that comma projects.id, projects.name, and projects.employee ID. So literally I am mentioning all the columns from the employee table first, then all the columns from the projects table. Okay, select these columns from which table? I am saying from employee table. Okay, but we have only 3 fields from employee. The others are related to projects table. Then here we need to add the join. So I am saying that inner join. Remember, the inner and join are also keywords of SQL. We can write them in uppercase or lowercase. I am writing it in uppercase so it is visible to you. So I am saying select all these columns from employee table, then join this employee table with the projects table. Inner join projects. Okay, how can we join these two tables? There is a common field. In the employee table, the ID is the primary key, and projects table, the employee ID is the foreign key. So that employee ID is a common field between both of them. So here I am saying that join them on. On is again a keyword of SQL. On in employee table, the ID should be equal to in projects table dot employee ID. So literally I am saying that join employee table and projects table based on these fields, that the ID of the employee table must match with the employee ID of the projects table. If I add the semicolon and press enter, okay, there is a problem. I have missed the spelling of employee. That is actually employees. So employees.id, employees.name, employees.manager ID, and similarly here the table name is employees. So that's it. Let's press enter. Oops, I renamed it in some places, but I left it here. On employees.id is equal to projects.employee ID. If I run this, it will return this result. We have ID, name, manager ID from employees table, and then we have ID, name, and employee ID from the projects table. What happened here? It returned only those records from employee table that had a matching value in the projects table. So we had employee ID for the projects A, B, C, D, and E, and the others were null. It means the employee ID was not present in the other records. Therefore, it returned only 5 rows. If we select all data from employees table, it has 10 records. Similarly, if we return all data from projects table, it has 9 records, but in the joins it returned only 5 rows because these 5 rows have matching records in both tables. So 101576 and 101576 are included in both tables, therefore only these two are returned. So that you can see here in this query that we are mentioning the employees table and projects table completely with every column name. So to avoid this, we use aliases. Let me write the same query again with the help of alias. So select, instead of employee, I can just rename it to a single character or 2 or 3 characters. For example, I am saying emp.id, comma emp.name, comma emp.manager id. What is emp? It is the alias that we are giving it to the employees table. We have not yet defined it, but we will define it in the from class. Comma, instead of project, I am saying p.id, p.name, and we can also use aliases here because we have id and name common in both tables. Let's give them aliases. So I am selecting emp.id as employee id, comma emp.name as employee name, and manager id is not common, so I will not give it an alias. p.id as project id, p.name as project name, comma p.employee id as, for example, project supervisor. Okay, so I'm selecting all these columns. Now I need to mention the from class. From employees table, here because we are selecting data from employees, we need to define that emp alias in this from class. So select this data from employees table as emp. It means I'm using emp as an alias for employees table. Now inner join, which table? Projects as p. So because we named it p in the columns, now we need to give that alias here in the from class. So select these columns from employees table as emp, inner join projects table as p, on which field? emp.id must match with p.employee id. So that's it. Add semicolon, press enter, and we have the same result with aliases. So this is employee id, employee name, manager id, project name, and project supervisor. So this is how we use aliases in queries. As I said before, whenever we write long queries and in joins, we need aliases, and this is a must. So we need to learn this. Now let's get back to our own e-commerce database and see how we can use joins there. So we have a table customer. Let me describe it. We have a table orders. Let me describe that. So in orders table, we have customer ID, and which comes from the customer table. So ID from customer is coming to customer ID of orders. So these two are the fields that are connecting the two tables together. So we can use the same join here. For example, select, let's not select all the columns, but select only the customer name. So select c.name from customer, and also email, c.email from customer, comma, in orders we are selecting not the customer ID, the order date. So o.order date and o.amount. You might have guessed it that I'm using C as for the customer and O for orders. So select these fields from customer table as C. Okay, inner join orders table as O, on C.id, it means customer.id must match O.customer ID. So the field in the the customer ID field in the orders table must match with the ID field in the customers table. So if I add semicolon and return this result, we can see that for every order we have the name of the customer and the email of the customer. Similarly, we have order date and amount. We do not have the name and email in the orders table, but with the help of joins we can fetch this data. Let's limit this, because again we are seeing all the data but we do not want to see all. So at the end we can use the limit class to limit the result to only 10 rows, so it can be seen clearly. So we have name of the customer, email of the customer from the customer table, and then we have order date and amount from orders table, but both tables are joined with the help of inner join. So as I said before, that inner join returns only those records that have matching values in both the tables. The second join is left join or left outer join. What left join does, it returns all the data from the left side table and only matching data from the right side table. The right side table where there are no matching values, it will return null values. For example, let's get back to employees and projects. So let me select star from employees first. We have 10 employees with ID 1 to 10. Okay, then let me select star from projects table, and it has 9 records. For 5 of them we have matching employee IDs, but for 4 of them we do not have any values. So if I say that select emp.star all the columns from emp table, comma p.star all the columns from projects table, from employees as emp. Remember that I am not mentioning as after this, because as I said before, we can ignore as. Left join, this time left join projects table as p, on join them emp.id must match with p.employee id. If I add semicolon, press enter, remember that it returned all the data from the employee table. See, we have all the values ID 1 to 10, all of them are present in the left side, but from the right side it returned only those records that have the employee ID. The projects that do not have employee ID are returned as null values. So left join will return all the data from left side table, but only matching data from the right side table. Let's reduce these columns to only 2 columns so we can see them in action. Select emp.id, comma emp.name, comma p.name and p.employee id. From employees table as emp, left join projects table as p, on emp.id must match with p.employee id. So if I press enter, you can see that ID and name of the employees table are returned, and we have all the records from the employees table. But from the projects table, again we have only 5 records, because these 5 records have employee ID there. The ones that do not have employees ID are not returned, but for these records which are included in employee and do not have matching values in projects, for them we have null values in the projects table. So left join will return all the data from the left side table and only matching data from the right side table. But the question is, how does left join know that which table is the left side table and which one is the right side table? It knows this from the order of the query that we have written. We have written EMP on the left side of the left join and projects on the right side. So any table name written on the left side becomes the left side table, and any table name written on the right side of the join becomes the right table. So in the left join, we saw that it returns all the data from left but matching data from right. We can use the same query, and instead of left join we can mention a left outer join. Both of them means the same, okay, and it has the same result. You might have guessed it that left join returns all the data from left and matching from right table. The right join will return all the data from right table but only matching data from the left table. If I do nothing but just change the left to right in this query, what will happen? It will return all the data from projects table. It means we will see 9 projects but only matching data from the employees table. If I run this, we can see that all the projects are returned from the projects table. We can see even the ones that do not have employee ID, they are returned because we are using right join. But only matching data from the employees table is returned. We have only those employees who have a record in the projects table. The ones that do not have a record are not present, and for the projects that do not have employee ID, for them the values are null values in the employees table. So right join returns all the data from the right table but only matching data from the left table. Let's swap the table names. From employees, I will say projects P, and I will instead of projects P, I will write employees as EMP. I've swapped the table names. So now projects is the left side table and employees is the right side table. If I run this, what will happen? We will see all the data from the employees table because this time this is on the right side, and only matching data from the projects table because that is written on the left side of the right outer join. So if I press enter, we can see that the employees data is returned completely because that is mentioned on the right side of the join, and only matching data of the projects table is returned. So whatever table name is written on the right becomes the right table, whatever table name is written on the left becomes the left table. The last join that we have here is the full outer join. What happens in full outer join? It returns all the data from both tables. For the values that do not have matching values, it returns null values. For example, if I run the same query, but this time instead of right join, I say full join or full outer join, it will return all the data from both tables. Let me press enter. First, we see the 5 records from the employee that have matching records in the projects. Then we have the projects that do not have matching values in the employees table. So for them, the employee's ID and name is null. And then the employees that do not have matching records in the project table, for them the values are null that you can see. So it returns all the data from the left side table and all the data from the right side table, but for those values that do not have matching values in the next table, null values are returned. We can also join multiple tables, not only 2 tables but multiple tables. For example, in the e-commerce database, we have customer table that has a foreign key in the orders table, and then we have transactions table where the order ID is the foreign key. So these 3 tables can be joined together because all of them have some common values with each other. Customer and orders can be joined, and then orders and transactions can be joined. So let me select c.name from customer, comma, o.order date from the orders table, T dot payment method from the transaction table and T dot amount from the transaction table. So the first column comes from the customer table, the second column comes from the orders table, and the last two columns come from the transactions table. So let me add from class. Let me capitalize from so it's visible clearly that we are changing the class here. From customer table as C, because we have used C here, so we are renaming customer to C for this query. Now inner join, which table? Orders. Remember, customer and orders are connected to each other, so we must connect them first. Orders as O on C.id must match with O.customer ID. So the customer ID in orders table must match with the ID of customer table. Now these two are joined. Now add another inner join, so we can join orders and transactions this time. Inner join transactions as T, because we have used T here, so we must rename this transactions to T. On the O.id, ID of orders table must match with transactions order ID. So there is a column by the name of order ID in the transactions table that is a foreign key and it matches the ID of the orders table. So orders table primary key becomes the foreign key of transactions table. So I think we have joined all of them. Yes. And if I add semicolon, press enter, it returns all this data. But again, we do not want to see all the data. We can just add a limit class at the end. So limit the result to 10 records. So this is the limit. Remember that we can use all the classes that we have used before in joins as well. It means we can use where class, we can use order by, and we can use all the stuff that we have learned before with joins. So joins does not limit your queries. It just joins the tables to you. Whenever we use where class with joins, the joins must come first and where class must follow them. For example, in this statement, in this SQL statement, we use select, then we mention the column names, then we mention the from class and joins. After that, we use where condition, where the transaction dot amount is, for example, greater than 8,000. Let's see if we have such records. Yes, we have. So all the amounts are greater than 8,000 that you can see, and we have 88 such records that you can see at the end of this result. 88 records are the records that have amount greater than 8,000. We can just add the limit class here as well, or let me before limit add the order by. Order by T dot amount desk is mean descending. So order this result by descending order. It means bring the largest values on top and smallest values at the end. So yes, it says that 9,000 is on top, and if we come down, the smallest values are in the last. We have 8,050 at the end. We can then, after order by, we can then limit the result. I'm just writing all the classes so you can understand the order of classes in SQL statement. We first used select, then we used from class, then we joined the tables. After that, we added where class, then order by class, and then limit class. If I press enter, yes, the result is limited to 10 rows only. There is another concept by the name of self join. Self join is nothing but one of the 4 joins that we studied before. It is either inner join or left join or right join or full join. Self join just means that a table is joined with itself. How and where do we need this? Just before you saw the description or the details of the employees table, where we had ID column, the name column, and the manager ID. Manager ID comes from the ID of the same table. So here we need to join the employees table with itself to see the manager of each person. Let's do this. Let me first describe employees again so you can see this. We have ID, name, manager ID, and manager ID. You can see that this is foreign key that references employees. It means this is a column of the employees table, but it references its own table again. It means we need to use self join here. Let me select the data from employees table so you can understand. We have ID, and the same ID is used as the manager ID. As I said before, there are some employees whose manager is ID number 3 and some employees whose manager is ID number 10. The ID number 3 is Jasmine and ID number 10 is Colin. So let's fetch the manager's name instead of the manager's ID here. So what I am saying that select emp.id comma emp.name comma manager.name. So instead of ID, I am saying manager.name. Who is manager? Manager is again employee. So manager.name means employee.name, but the role is manager. From employee table as emp, inner join employees table again. So I am joining employees with employees but with a different name. So because for manager's name I used m.name, I am renaming this employees to M. And how to join this? On emp.manager ID should match with manager.id. Remember, emp.manager ID, it means the manager ID of the employees table must match with the ID of the employees table. So if I run this query and from employees in, okay, I just use employee for employees, so I need to rename this. I am repeating the same mistake over and over again. So let me run this again, and we can see that for these employees is Jasmine is the manager, and for these employees Colin is the manager. And remember that Colin is not returned in this result. In the employee name we do not have Colin. Why? Because we have used inner join and Colin does not have a manager ID, so that's missing. And we said before that inner join only returns those rows which have matching rows in another table. If I select star from employees, we have ID number 10 Colin with missing manager ID. That's why we have 10 records in employee but only 9 records in the joins result, because we used inner join. So here we can see that ID number 3, who is Jasmine, is the manager for these 4 employees, and we can see the Jasmine name here, Jasmine name. And then ID number 10 is the manager of these employees, so ID number 10 is Colin, and we can see that Colin is the manager name for those employees. So self join is nothing but one of the 4 joins that we studied, but in self join we join a table with itself. That's it. So in this video we studied null values, order by class, limit class, and different types of joins. I hope you have learned all these concepts. Make sure you practice all of the stuff that you have learned here, and if you have any questions or any problems, make sure you comment this under this video and I'll come there and answer your questions. This is the last video of week number 7. From week number 8 we will continue the advanced SQL topics, and then we will have 2 projects as well. Thanks for watching.